bit of context. We were short a presenter last month, so I whipped this out. This is actually a copy of a presentation that I gave in May at DevWorld. The tickets for DevWorld were quite expensive this year. Worth it, but quite expensive. So if you're unable to make it to that, this is your chance to see some of the content, basically. We were going to do this last month, but issues with proxies and other things meant, we actually got the first legitimate use of the technical difficulty slide, I think, last month. But there was some calls or people who were disappointed that we couldn't do this last month. So we're going to rehash it this month, even though it's a little bit of a repeat. All right, anyway, let's get going. So the bulk of this is actually going to be code and demo. So don't worry too much about slides. The first probably 30% will be slides, just to give you a bit of context if you don't know what OpenTelemetry is. If you do know what OpenTelemetry is, or telemetry in general, you can probably go grab another drink and come back in about 5 minutes or so, and we'll get to some new stuff. So that's probably the first bits. First 3 bits will just be some context setting, and then the last 2 bits will be where the meat is. And hopefully we have prayed to the demo gods this evening because it didn't work so well last time. Everything I think is working all right now, so we'll find out soon, I suppose. Let's crack on. So what is distributed tracing? First, this is going to be the really, really, really basic intro to what it is, or more generally, what is tracing? This is probably where we all start when we're trying to figure out what the hell's going on with the code that we write, right? You've got print statements, you're using nslog, or you're using logger, depending on where you are in your Apple logging framework journeys. We're probably all on logger by now, right? But print will never die. Print lives forever. Go print. You might even, if you're pretty good at it, you might even capture some of this and send it off to your backend so that you can actually have some idea of what's going on. More likely, you've probably picked up a New Relic or a Dynatrace or something and running with whatever the default out-of-the-box tool that your business has asked you to use, right? But this is all pretty basic, so we'll go back to the basics. You can see in this example flow, someone's tapped on a transfer button or a transfer confirmation button, or tap the button. We've made a call to make you can guess the bank references because I work for ANZ. I think I skipped over the intro bit, but that's all right. You make a call to your API to do the transfer. You might get some data back about the transaction that was made, so you can populate your local database, that sort of thing. And then you might show a receipt screen to your user. And that's a pretty straightforward journey as far as that goes. You might also, on the last line, if you're doing things reactive, update your transactions screen to show the newly inserted transaction data. That's fine. It's all very helpful. Let's break this out a little bit more so we can see what we're doing, right? The next step on your journey might be something like this, where you can move on to structured logging rather than just straight text, one line of text. If you're using something like Swift log, and if you've done anything on Swift on server, you'll probably have a little bit of that in your life. You can pass key value pairs into Swift log now to add metadata to the log event. And then bonus points if you send the Swift log stuff or your other structured logs to somewhere like even an S3 bucket or somewhere where you can actually see them. Hopefully you're storing it somewhere a bit more secure than that, but you send it somewhere and you can actually start to write queries against this. It's basically a table of data. You want to know what's happening for a particular user, you can query on the user ID. You want to know what's happening for a particular URL, you can query on your URL. All of that sort of stuff is there to start getting you some more aggregate information about what's going on in your life. But there's no relationship between any of this. I've pulled out a nice 7-line example. So it's really easy to see what's happening, especially given the previous slide. But if you have tens of thousands of lines of this per hour coming in, for a few thousand users, it can get really confusing really fast. And there's no real way to associate them together as a structured log. But let's try and make that a little bit better. So what if we would try and add some relationships between these? Let's just clean this up a little bit to make it a bit easier to follow. So let's first of all add just a unique ID for each of these log entries. Typically you would use a UUID but UUIDs don't go well on slides, no matter how small you make the font. So we're going color-coded, and we're going a straight number. Makes it nice and easy, right? So let's add a relationship between them. The most straightforward and easiest relationship, and the one you get the most benefit from, is the parent log. So you can see the relationships we've got here. That's in number 2, when you tap the transfer button, it does 2 things. It calls the post/transfer, and then it calls the number 4 as well, gets the transaction details back. You can see that number 4 triggers the insert transactions data. So when we get the response back from the transactions table, we insert it into our local database. We can see it's actually the insert statement that triggers off the select, which means it's probably a reactive reload of that information that's coming through. And then the very last one is we're showing the transaction receipt screen, which is actually triggered by number 2. So that's actually the tap transfer button that comes out. Helpful, but again, tens of thousands of that, not so good. So let's change how we're representing this a little bit. Magic move, such a good thing. Yeah, the magic move always deserves a clap. And let's put the names back in so I don't have to try and remember numbers, makes it easier. So this is actually a trace, right? Rather than individual log lines, this is a trace coming from a root action or a root span. To be more specific, this is a timeline view of a trace. We had the linear view before. This is more of a timeline view. So I won't run through all of that again, but you can see it encapsulates its parents in the vertical, and then it's obviously X over time, left to right, which I probably should have put as a graph on the thing. Doesn't matter. I'm hopefully not giving this presentation for a 3rd time, so I'm not going to bother updating the slides. So yeah, you tap the button, makes a couple of API calls, it deals with the API response. There's some other things that are kicked off reactively, but you can see it all in a nice visual timeline of what kicked off what was related to what, all of that sort of stuff. What else did I have to say about this? Oh yeah, but this is a great thing, and if you've got this, it's very helpful. But this is a talk about distributed tracing, not tracing. What makes it distributed? Well, if you propagate your trace information and your backends are logging to the same data source or data store as your front ends, then that trace information, which starts with you tapping a transfer button, can include on the one tree diagram or timeline view everything that your backend does as well. And this is when it starts to get really good, because you're not going into, say, New Relic, figuring out what's happened in your customer app, and then going to a different system like Splunk or a different log ingestion tool, trying to match up source IP addresses and times to figure out where the call came in and then figure out what happened on the back end. One tap and it's all there, all on the one screen. So you can see when you call tap transfer, the back end does some validation, does some magical fraud checking thing. We even call out to a third-party unicorn service to do our fraud checking, because that's how bank fraud checking works. I'm not recording this, right? Whoops. The secret source. And then we post to a ledger, for example, and then you've got your second call where we would get that ledger, and then so on and so forth. So that's a trace. All right, let's talk OpenTelemetry, because that's the specific bits that I wanted to get to tonight as an introduction. This starts in the same place that they all start. And it's actually, is it 14? Yeah, 14 is pretty close, actually. There's quite a lot of different tracing standards, but that are out there. But unlike the typical scenario, this one, the industry actually got together and worked on it together. So fingers crossed, if this one is fit for purpose, we won't get to 16, but who knows, right? I do actually have some numbers here. So there's 68 different vendors who had their own proprietary protocols, got together to come up with OpenTelemetry. And most important bit for what we're concerned here is this is an open standard, and 17 of those 68 vendors have a full open source offering for their backend data and data ingestion. You can run it all up in a container if you need to. You know, especially if you're concerned about privacy and don't want to hand it over to some your Google and your Firebase or your New Relics, all those sorts of things, you can run it locally, or you can run it on your own little server, and you're responsible. You know what happens to the data. And you can also say goodbye to vendor lock-in, because the typical setup for this is to run what they call a collector, which is basically a proxy. That then means you can route telemetry where you want to. So if you want to send really, sampled data, like high-level data to your analytics tool, you can do that. If you want to send really granular data down to a log somewhere, you can do that as well. But the best bit is, if you want to break up with your current vendor, just start sending your data somewhere else. Obviously, history is a bit harder, but you're not stuck with them forever. That lock-in is a lot less. So, OpenTelemetry. OTel actually has the 4 different types of signals that can be sent. Traces, metrics, logs. Logs I don't think we need to explain. That's pretty much the structured logging example that was there before. Metrics is very helpful, but we're here to talk about traces tonight, so we'll focus on that one. In OpenTelemetry parlance, what is a trace? I took that off from direct off the website, but we already really covered that in the first section. The only thing that's probably different is that each of the individual log lines in OpenTelemetry is called a span. So each of those spans is on the left there, on the right. Right, your right, my left. And you can see that they correspond pretty closely to the ones that we had on the diagram in our first section, because this all come from the same data set. And they also have unique identifiers. So you can see the trace ID is the one up the top. So it's all the way through. The actual spans themselves typically represent a named block of code. So you're running a block of code. It takes a certain amount of time to run that code. You have some context around where that code was started. So it was started within a trace, what its parent span was. You usually give it a name, makes it helpful. And then you can add attributes to it, which is the metadata that we had in the previous bit. And the last bit there, in some senses, spans and functions are the same. In some, they're not. You might break your functions up nicely for unit testing, but it doesn't really make sense to have, 4 functions representing one larger block of code in the thing. The granularity is entirely up to you on all of this sort of thing. And the last bit is when you cross system boundaries. How do we cross system boundaries? So when you make that API call, you tack in what they call a trace parent header from the W3C trace context spec. Again, another open spec that they built on top of. You pass in that trace parent header, which has the trace ID, the span ID that made the call, and any flags that we need to pass across. And then in the server side, they consume that, and then they start their own tracing from that as the parent. And then when you end up in the tool, you can see the parent cross the system boundary. And we'll show you that in a minute. All right, skim through this. Practical bits if you want to actually have a go at it yourself. The first thing is do not use the official SDK. It's garbage, absolute garbage. It's basically just as somebody's run the Java SDK through Copilot or something. I don't know, but it's a horrible thing, and it's not very Swifty at all. So don't use that. Apple provides some things in this space. They've got the Swift distributed tracing one, which is the one I'll use in the example. It's designed, and these are all designed for Swift on server, though. So while they do work with in apps, there's a few hoops you need to jump through to get them to actually work properly with iOS. It's one of those few libraries that works better on macOS and Linux than it does in iOS and watchOS and family. But their stated goal is to be flexible, so while they're not specific to OpenTelemetry as well, you can hook into the OTel exporter, which is the one that they recommend there as well. Okay, 2 bits of code, 3 bits of code. To create a span, really simple. You just go try array with span, or there is also non-async and non-throwing overloads as well, so whatever you need. But the trick is to call with span, give your span a name, and then do whatever your thing is inside of it. That's it. Just wrap it in a closure block, away you go. To add attributes, the first argument that I was ignoring before is the span. You can just go ahead and tack the attributes that you want onto it. So if this is an example for a post call to an API, and we'll actually go into a bit more code for this in a minute. But yeah, same thing with span, post to path, add in the, somebody fix that. So it says post instead of get. Anyway, nobody picked that up on the first round. It's funny. But yeah, so you do that and then you make your call like you normally would, right? It's designed to be a minimal wrapper around what you're already doing. Oh, I spoke to the slide already. Okay, you can skip that. There is some good news though. If you're in Swift 6 land or in Xcode 16, you don't need Swift 6 for this one, just Xcode 16 is fine. You can write a function body macro that does the same thing. And it just means then that you've got your method. You can attach a @trace macro to it that does very much the same thing. Nobody provides this yet, I don't think, in any of the frameworks, so you'd have to build it yourself. But I also haven't looked at Swift distributed tracing since May, so maybe they've got a... Do you know something? You had a funny look? No? I have written one of these myself. It's pretty straightforward. It's very, very easy macro to write. But then it means that instead of having to do this every time, the boilerplate is just done for you.
That's why it's the same method.
Yep. Copy paste. It's great. Absolutely great. All right. So demo. All right. So I have been 15 minutes on slides. We're still at 7:25 though, so we're doing okay. So we'll jump into a demo to run through some things. We'll get a quick overview of the app architecture first. And before that, I need to introduce you to BokBank. So BokBank is a brand new neobank. This is one I use for all my demos now. And it definitely wasn't written in 4 days before the conference talk last time. It's really definitely a highly secure and performant banking institution. And it's got a reputation for disruption, innovation, and trend settings. And we need to do the reveal. We have t-shirts, yay! If I can get it off. T-shirts are definitely the best bit. Any excuse for a t-shirt, right? All right, let's look at architecture. We won't spend too long on this, but it's just basically to say we have a server, everybody has a server, and in our server, we gave each customer a SQLite database. No sharing data with other customers and their dirty, unwashed money. You'll get your own database, so there's no chance of any cross-contamination. Everybody gets their own database. And not entirely at all, because that's easier to write with GRDB than it is to try and do Postgres on the backend. So nothing like that. When the app starts, we open a WebSocket to the BokBank API. It syncs your backend database with the client-side cache. Pretty straightforward. Any changes that occur to your backend databases are automatically replicated down that WebSocket. Another reason for using GRDB and its value observations. Hopefully when we get into demo, you'll see that the traces run all the way through the chain too, and they should. I check that. And most importantly, because we are a lovely progressive bank, everything is written in Swift. Front ends, back ends, all in Swift, all in one project, because that could never possibly go wrong, right? And the source code for this is online if anybody wants to play around. It's all up on GitHub, has been up there for a while. Haven't broken anything yet, I don't think, so it's good. Let's switch over to demo time. And let's see. Mirror. Mirror, no, I don't want to mirror to any of those. Is that working? No, that's just mirrored to my phone. My other laptop. Sorry, Pat. That was absolutely not meant to happen at all. Hopefully the stream stayed up. Let's do this the old-fashioned way with the settings. Use as main display mirror. That's better. All right. So what's in my demo notes to run through? Show app in Xcode. everybody knows what Xcode looks like. You can see in my project, we've got the main app, the BokBank app is up here. The server stuff is in the same project down the bottom here. And you can see in the main apps package that we have a dependency on the server as well. So we share code between the server and the app. Makes it nice and easy. If we go down to the client, the main thing we share between them is their data models, so we don't have to have any sorts of inconsistency, and it means that we're always building in sync as well. Great for demos. Really good for demos. All right, come off that for a bit. Next bit is Safari. Now, this is let's go back to the home page for that, rather than where I was. This is a telemetry platform called Honeycomb. I like their UI, it's nice and easy, but they are a paid vendor, so it's all the niceties that come with it. They do have a free tier, and I can recommend them, they're quite good. But yeah, if you want to stick in open source lands, you've got things like Grafana or Jaeger, and one other one that I can't remember off the top of my head. But those are the main ones. And as I said, there's 68 different vendors. Most of your big tools support it now, so Splunk can support it, all of that sort of stuff. Everybody supports it. So this is the overview of all of the spans that are coming in for the server. And there's not 2,000 and whatever it is, because there's several different fake things doing postings all over. Fake data is good, makes stuff for nice demos. So we've had 2,617 spans traces come through in the last 30 minutes. And this is the server, as I said. We can switch over to check the app. And the app won't have anything because I haven't done anything in the last 30 minutes with it. But if we expand it out a little bit, or a bit more than that. I was doing testing yesterday, right? Yay! So we saw 5 traces in the last 24 hours when I'm doing some testing on that one. The difference between the two is just how we're grouping them. We group them by service. They create a new data set for each service. You don't have to group them this way. You can group them however you like. All right, let's have a look at some boards, and we'll switch back to the project that has data, because that'll be more helpful. Am I doing boards or queries? Boards. So you can create some basic dashboards for the stuff that's coming in. Again, this is all custom. You can see API calls and durations. So most API calls, like the P95 for API calls, is in the 60 to 100 millisecond range. Not because it's local, but because we're just that good. And you can see the different API calls that are being made. Most of the calls come through to the accounts one, with some merchant info and other things as well. And I'll show you the app in a second. This will make more sense. And I should have populated some failure data, so that looked better than 0, but it is what it is. So what the data actually looks like. Let's go to our query page. So in the last 2 hours from our timer here, we can just run that. We can see my scripts have been running hard, and we've had, what is our granularity? Every 15 seconds. Let's move that to a minute, so it just looks an easier story. We can see that per minute we've been getting about 485, 400 and something-ish coming through, or about 8 a second requests coming through. And this is all events, so all spans, everything. Let's have a quick look, dive into something a bit more specific. So you can search and filter on any attribute, including the name. So let's start with the name, right? The span name is the one that we put into the with span bit. So if we look for, no, it won't be post. Let's look for get accounts, get/accounts, and search for that. So this is just the accounts requests, right? So there are approximately 60 per, whatever that granularity is, still a minute. About 60 a minute, or 1 a second, 2 a second coming through. And we can dive in to see what that actually looks like down the bottom here. So we can see for this first event, the time that it happened, and all of the attributes that we've attached to that. So you can see the duration is 1 in milliseconds, so 1 or 2 milliseconds. the ID of the user, the HTTP method. This is actually a GET this time, not a fake one. The other, the HTTP details, library info. What else is important here? Service name is our grouping. And then the other stuff that's there. So the trace ID is the unique identifier for the trace, and the span ID is the unique identifier for the span. And that's attached to all of them. And you can query on any of this. We queried on the name before, but I could just as easily go in and say, query on this HTTP status code. Like you can actually click on that and say, show only where it has a status code, where it is an error, where it's not an error, filter and drill down all the way through. But that's just, that's a structured log. You can do that with Splunk as well if you want. The cool bit is when we get into this. And this is just the server-side trace because there's no actual client running. So we'll get into that in a minute. But this is the trace as far as the server is concerned. You can see we've called /get requests, and it has done a database query, and it is called, to do that, is called select star from account. And the user that's involved was on that. All right, so that's enough for that bit. Let's look at code. Let's look at the app. That's what I'm doing next. So this is our app, BokBank. It's maybe heavily inspired by the ANZ Plus app, but I don't know if you could tell, but it looks pretty good, I think. I spent all of 3 hours trying to come up with that nice layout and get it looking good. I think I pinged you at like 11 o'clock one night to get it fixed up. Yeah, thanks, Pat. So that's it. It's syncing all of this to its local client. It has obviously list of transactions. I don't think I have a transaction detail screen. No, I didn't do that. But we have the account balance. This is your transaction account. It does support other accounts as well, but you can't see that in the UI yet. But what it does do, and I'm gonna, all right, let's risk it. Here's one I prepared similar. Hopefully they're connected to the same, they should both be connected to the same server, but who knows with demos. Let's do a transfer. So if we want to transfer from our transaction account to the savings account, and we want to transfer, let's say $33, we do that. Yay, it works. I'm amazed, absolutely amazed. And you can see both are in sync. Right, so that's a pretty basic demo as far as that goes. The real magic is when we come back to this, and this is where we find out how good the demo actually was. So we go to query. Let's go to the app. And please let there be, yay, actual data. So what we want to do, let's find that transfer request that we just made. I don't remember what I called this anymore. Let's have a look. Post/transfer sounds good. Tap transfer now. I wonder if it works that far deep. All right, so we can find, this is the trace that we just did. And we can click on that and we can view that trace, and fingers crossed, there we go. Very good, it works. So you can see here everything that just happened on both sides of the fence, and not only both sides of the fence, but more. So you can see we tap transfer now. That caused it to trigger a request to /transfer. That's great. And then we crossed the system boundary. So we've gone from blue to green, and colors are done automatically, but we're now running on the server. So this is what happened on the server, all associated in the one tree diagram, so you don't have to go try and figure it out and do the correlation yourself. It's all across that way. We can see we did a magic fraud check, which took 320 milliseconds or so. I may or may not show you the code for that. And then we can see what it actually did with it, right? So the server, it made a select call. It selects star from account, where ID equals something. So it's grabbed some account details for a specific account. It's done that again. So select star from account, where ID is something. We've then made an update account one, right? Where we've updated the accounts and saved it back again. We've done the same again, updated accounts, saved it back again. We have inserted a transaction. We have inserted another transaction. And then we start sending stuff back down the WebSocket stream to the client. And you can see here, we're sending the transactions that we just did, and we can see the app receiving that transaction again, same thing. So we've gone full round trip, all in one tree diagram, no needing to figure out what's going on. And you can see that the app received the transaction, it updated it, or it attempted to update it, because GRDB will do an update first, and if that fails, it'll go back to an insert. So it attempted to update it, and then it inserted the transaction. It sent the second transaction, did the same thing. It sent the update account details for both of these, and you can see we're getting them coming through. Update account details there as well. This is then, because I had two devices running side by side, it sent it to all of them at the same time, but I didn't quite have that working for the demo, but it sent them to the other devices as well. Oh no, this one did work. But yeah, so you can see we've sent it to two different end user devices. That's come through, and that's end to end, full tracing set up there, which is very helpful. And that's all I have for demo. Oh, code. Right, so I knew there was more to this. Let's kill that. All right, so code. So when we start here, actually, I should just be able to search for tapped transfer. Oh. Nope. Am I on? Nope. No.
Oh, you misspelled tap.
Trapped. That's how I feel right now.
And again.
Oh, come on. There we go. Okay, so you can see we had a transfer form, and we're doing a span inside your view. Probably don't look at this, Pat. Don't look at this, Pat. Yeah, don't look at it.
I like code in general.
So you can see where the user has tapped on the button. We then go and call the payments client to make a transfer, which then calls this bit. And all of that does then is creates a transfer request, calls a post request on /transfer with the request body that we put together. The request is just the source account, target account, the amount you want to transfer. If we then have a look at that, you can see this is, we're using async HTTP client here, I think. So this is just setting up to make a post request with the JSON format, blah, blah, blah. This is where things get interesting. So same as what we saw before, we just call with span, we call the method the raw value, so post, and then the path that we want to send. It's a client span because that's just nice with the way the spec works. We set our attributes, so we do all this manually for this particular one because it's a demo. We set the host, scheme, targets, all of that sort of stuff. We then create the request. We add in that span context. So the span context is how the Swift distributed tracing knows where you are in the current path of the stack, and it does that using task local values, so it knows where you are. Grabs the span context, we inject the span context into the headers, which sets the trace parent header, and then once we've got all those headers, we log them. So we can actually go back over here to this one, and you can see, I think, HTTP header trace parent. Damn it. Damn it. Too much zoom. So you can see it's set, right? Set the host, set the method, content type, and the trace parent header has come through. That's all there. Lovely user agent, all of that stuff. We make the request. We update the response once we've got it back, and that's it. And that all gets sent off as it goes. We can then have a look for the last bits of this demo is to what happens on the server code, because it's all in the same place. First thing we have is we're using Hummingbird for this one. I don't think it's Hummingbird 2, I think it's pre-Hummingbird 2. But we set up a middleware to do all of this, the tracing for us. Hummingbird actually has something like this built in, but I needed to do a little bit of extra stuff. So you get all of that for free with Hummingbird, and Vapor has the same if you're running Vapor Stack. They have all that for free. So you handle the request, we grab the service context, and then what we do is we start a span with that service context that we've pulled out of the headers. So that's how it then links it back to where it came from. And then I won't go through that again because we're just updating the attributes on the other side with all of the HTTP details that we're supposed to have. Blah, blah, blah. I don't think there's anything in particular there. We do save somewhere in the middle here, we save the current span into the context for Hummingbird, so we can, in our other middleware, inject and update things. So this middleware does some authentication, access control, or it will eventually one day. And then we just, once we've figured out who the user is, we add the user to the span so you can see what's happening. Let's see you track all that through. And then, so this is where we receive the post requests or the transfer requests coming through. We do some magic fraud stuff after we've decoded it. And then we just make the transfer in the repository once we're sure that it's a secure and legitimate transaction. And this is where most of that bit comes in. So we write everything to the database, we fetch the source account, we fetch the target accounts, which is those two fetches that we saw here. That's probably jarring going from white to black. So those are the two fetches that you see here. Then we've got 2 updates and 2 inserts is what we're expecting to see. So we make the transfer by decrementing one account balance and incrementing the other. And then we create some transaction records for each side. One, the source transaction, and one was the receiving transaction. And then the 2 updates that you saw were us saving the account balance. And then the 2 inserts you saw were saving the transactions. And then we send, I won't go into the other bits, but that's pretty much what you see for all of this bits here. So let's see if I can switch this off better than I switched it on. No, we're just going to display settings. I don't know why they made this so hard. Stop mirroring. So that's it for demo. And it's going to wrap up. That took a lot longer than I remember it taking the first time. Hopefully this has been a helpful introduction to distributed tracing. The few things that I wanted to actually, before I summarize, there is one last thing to come. And this is the most important bit, right? Even though you might be getting rid of your Firebases or your New Relics, getting away from a vendor and running something yourself, doesn't negate the fact that you still need the user's permission to do any of this sort of tracing stuff, and you should still always respect that. If it's revoked, stop tracing. Same as always. There's nothing here just because you're doing it yourself that somehow makes it better or more palatable to snoop on your customers. Same rules still apply. That's it. That was it. The source code is there. I think that's the QR code for the source as well. That's my Mastodon. The bits that we wanted you to take away from this is you can get away from your vendors. OpenTelemetry is a thing. It is still quite new though, so you'll be implementing things yourself, but that's actually a good thing generally because it can be specific to what you're actually building, what you're delivering, and there's no swizzling or magic involved. You're not just picking up a New Relic and whatever data they give you out of the box is what you get. You're doing it yourself. That's it. Any questions? Questions? That way.
I noticed lots of question marks in the logging, which looked a bit kind of like SQL statement. Was that intentionally masking sensitive data, or
that's just how I did my GRDB integration?
Okay. Do they have some sort of special thing for intentionally masking data? No.
Yes. So at the collector level, there are redaction rules that you can set, and they do have some smarts around that. But as always, you tend to want to rely on that yourself. In this case, the GRDB to span stuff I wrote myself based on SQLite tracing. And we take the prepared statement, but not the detailed statement. So that's just what we get back from SQLite before we send it up. But yeah, you can do all sorts of redaction and routing and stuff in the collector if you like YAML. If you don't like YAML, don't look at the collector. It's one gigantic YAML file, basically.
Thanks for the talk. That was really interesting. I'm really curious. You were saying don't use the OTel base SDK, the one they provide. I've used that myself, and it is very, very, very messy. But you said that you had to do a lot of workarounds to get the Apple server SDKs to work properly. I was just wondering if you could elaborate a little bit on that.
It wasn't so much and I don't remember. I can You'll see it because I had to fork a couple of things, and you can see what commits I've made in the demo repo. I think it was more to the OTel, this one, the OTel Swift library, because there's a Swift on server thing. There's a few cases where they don't support iOS properly. And it's just a couple of conditional compilation statements, I think, from memory. I don't think it was anything too dramatic. And I did go to upstream those and then properly forgot all about it after the talk. So yeah, it wasn't too much, but Swift distributed tracing, I think, worked out of the box without issue. But yeah, because Apple platforms are not their target, you can sometimes find a bit of edge cases on iOS and other platforms.
Questions?
Okay, this question may be a bit out of context, but
Okay.
how do you deal with retention policies on your data?
Good question. That really depends on your vendor. In this case, for Honeycomb, they have retention policies that you can set. I'm not mirroring at the moment. Do I want to risk it? I still got settings open. Let's risk it. Mirror. So for Honeycomb in particular, if I go to, I think it's team settings or data settings. Might be data settings. For each of my data sets, I can, yeah, maybe something. It depends on the retention. Here we go. So in Honeycomb, you've got some level of control over your retention. This is set to 60 days at the moment, and that's their defaults. I'm pretty sure that's their defaults. But if you're rolling your own open source backend, Grafana Tempo has settings for that. But if it's all on your own infrastructure, that at some point you can just go in and say delete all where date altered that as a cron job if you had to, right? That's part of the benefits of taking ownership of all of this sort of stuff, is that you're not at somebody else's mercy. You own the data. The data is yours. You can delete what you need to delete. Did that answer the question?
Yep.
Were there any other questions?
Yeah, maybe for a completely beginner. So for a single span, or a trace, how would you define when should it be stopped? Maybe because a complex system may have chain effect of you receive a transfer. Maybe you have UI effect to update your balance. And for a single trace, how would you define this is a single span and it should not extend to another span?
That's one of the benefits of this, is that it's all in your control. You're not beholden to what somebody else says a span should be or a trace should be. For guidelines on that, there are a whole bunch of people have written a whole bunch of documents on what you should and shouldn't do, and it's still early days for this, so there's lots of debate about how you should do that. The Swift distributed tracing is designed to work with async await, and structured tasks or unstructured tasks. So that's a pretty good boundary for what a span should be. If it can run in a task block with task.init or in a function that you can try await, it's a great candidate for a span. If you're trying to wrap a span around a long running operation, that's a lot harder. And you have to ask if there's value in doing that. Actually, I will show one here. I should just leave it on bloody mirroring. Anyway. So I can show you an example of that, right? If I can remember where it lives, in the query, in the BokBank server, there should be name equals, we should be able to see it here somewhere, sync. So the accounts per second, if we look at the visualization for the P95 of the duration, which is maybe not helpful after all. Let's have a look at the trace. No, it's not helpful after all. Might be better on the client side, but we've got so this is the WebSocket request, right, where we're doing syncing, and it's keeping the connection open and when the connection closes, it reconnects. So in that one, I actually dropped it off a little bit because there's not a lot of value in a span that runs for 24 hours. Like, you're going to see a million events. They're not going to have a reliable parent. So that's one of the things that you figure out as you go through. Yeah, probably. Where did you see that?
It's on the first page.
That one? Yes, WebSync, WebSocket sync. There you go. So I deliberately don't associate any of the events that happen inside that sync. I don't associate with the parent trace because there's no value in seeing a billion, events happening inside that one thing. They instead get associated with the event that triggered them in the first place. So they'll show up in the transfer one rather than in the WebSocket one. And I didn't set up any links, no. Purely, and that's up to you to find where that value is. Like, for long running stuff, if it's going to take for ages to run, maybe that's great because you want to be able to alert on that. So Honeycomb and a lot of these tools have SLOs and triggers built in. So you can see if it starts taking, 4 minutes instead of 2 minutes. You might want to trigger an SLO on that. All of those sorts of things are there that you can do. But yeah, it's really up to you to decide what the value is. And again, that's the good bit, is that you can do whatever you want.
Okay, one. Can you easily turn it on and off, or increase the amount of tracing, or is that just your own responsibility?
Yeah, it's your own responsibility. Yep. We've had those discussions before about doing that. Would be great, if you had log levels in OS log, for example, where you can just by default send only error traces through to the server, and then you can drop the log level down or increase the log level for a particular user, all of that sort of stuff. You're better off just sending everything. It gets batched up and sent as one blob of, they use gRPC for this. It's all zipped up, so it's binary, pretty small. And then at the collector level, you can filter off that. So you might do sampling by default, but then if there's an incident or something else, you can turn sampling off and just flush all data through. Depends on how much data you like having and how much it costs you to store all that data and all of that sort of stuff.
Yeah, that raises another question. So in your slides, you had that spiel, which I think was Apple's rules about needing to disable or toggle.
Yep, always respect
collection.
the user's consent. Yep.
If you did that as the collector rather than an app, are you adhering to that rule?
I would say no. But I am not a lawyer, but I would say no, because you're still sending that data off device, even if it's, I think as a hard and fast thing, you respect the user's consent. But if you have the user's consent, what you do with that, you can raise or lower as you need to. But yeah. Fletch.
Is there a Shopify store for buying BokBank merchandise?
As a member.
Yeah. I forgot to do the spiel. I am looking for investors. If you've got lots of money and want to start a bank, let's go.
What's your interest rate? I'll invest if you.
Well, we'll talk after.